Okay, so let's get started. And uh, this is another perspective on cognitive development. In the last lesson, uh, you learned all about Piaget and Vygotsky and the traditional theories. In this lesson, I kind of want to start to touch upon the way we see cognitive development and its application to neural networks and computers and whatnot. Now, when we reviewed the different theories in lecture one, we also talked about information processing. So that this will be more of an elaboration on that. All right. So when we talk about the information processing approach, it tends to view the mind as a complex symbol manipulating system through which information flows much like a computer. And to me, I think the computer analogy is a good one because it highlights how we store information and how we make connections between information. So let's start talking about the store model. So when we talk about the store model assumes that we hold or store information in three parts of the mental system. There is the sensory register, there is the short-term memory, and then there's the long-term memory. Now, the sensory register is things that trigger or activate one of our senses. Then it should be processed to short-term memory. Short-term, it's referred to as short-term memory because it's both limited in time. Typically, your short-term memory, you're holding on to information for seconds to minutes. And it's also limited in terms of short-term memory, it's limited in its capacity. You usually can only hold about 7 bits of information at a time. And then the third store model is long-term memory. And I like to describe long-term memory sort of like the cloud. So we used to have flash drives or floppy disks or all these things to save information on. But now, because there's an online network, we can save information online, and the cloud is limitless, or it's limited only by the amount you pay, assuming we're talking about the iCloud. So sensory register, we talk about things being activated in one of our sense organs. Short-term memory, we're holding on to information for a limited amount of time. And long-term memory is where things stay. And if a memory gets all the way to long-term memory, you can access it at a later point in time. So we also talk about mental strategies, or so as information flows through our information processing system, we use mental strategies to transform it. Things like mnemonic devices will help you bring things from short-term memory to long-term memory. Things like hierarchies and chunking and things like that will help you bring things from the short-term memory to the long-term memory. So let's talk about the sensory register. Again, it could be any of your sense organs, but human beings, we tend to rely most on vision and auditory functioning for survival. So you might have an iconic memory, and an iconic memory is just a fancy way of saying something that triggers vision. And that is going to be in your sensory register. So think an icon is something you see on your desktop or your phone or whatnot. So that would be an iconic memory as one way of activating the sensory register. Another would be an echoic memory. Think echo, echo, echo. So this would be more of an auditory process or an auditory input from the environment that triggers the sensory register. As I said, it could be other things. It could be taste, smell, or touch. But ultimately, when something hits the sensory register, you have a decision to make. Is this information important? Do I need to respond to it? So, for example, if you hear, right, if you have an echoic action, so if you have a sound, a loud boom, within a split second, you have to decide whether that loud boom is something that you need to concern yourself with. Well, depending on the context, that loud boom is going to be either more or less threatening. So if you're at a birthday party and you hear a loud boom, it's likely either fireworks or it's likely a balloon popping, to which you might have a startle response, but then you don't process that information more than, okay, that was a balloon, and you move on. As opposed to other situations, you're at a mechanic and you hear a loud boom, you might interpret that as a muffler backfiring, and that requires a little more conscious attention because if that's your muffler, then you need it repaired. Versus a third situation where you're in war and you're a soldier and you hear a loud boom, obviously that's going to require the most attention of the three. So depending on the context in the environment, you will decide whether that's important to move it further or not. So some auditory visual stimulus activates the sensory register. If you deem it to be important, it will naturally move to what we call working memory or short-term memory. And as I said, working memory is referred to as working memory because you're still working on it. It's not in its final state. Or short-term memory because if you stop working on it, you will forget it. So I know that today this example might be a little bit less relevant, but I want you to imagine that you are trying to remember a phone number. And you didn't have your cell phone with you, you didn't have a pen with you, and someone gives you their phone number and it's important. Well, one of the things that people tend to do, and remember how we talked about mental strategies, is to rehearse or repeat over and over and over the number. So you might walk down the street saying 555, 5555 over and over and over. But what happens if while you're repeating the number, something else happens and there's some interference or a distraction? It's not uncommon, because it was only staying and being maintained in your short-term memory, that when you try and access the phone number after that interference, it's gone. So we need more than just a repetition or rehearsal. We need a more elaborative mental strategy to bring it from short-term memory to long-term memory, right? So what directs that process is what we call the central executive. So this is a special part of working memory that directs information from between sensory to short-term memory and short-term memory to long-term memory. Now, I don't know if any of you have seen the movie Inside Out, but that movie, albeit a Disney cartoon, is one of the more brilliant movies when they try and explain things like memory and how memories are encoded and how memories are stored and how emotional events can color memory, or the accessing of memory could be impacted by certain events. So if you watch the movie, you'll see the process by which these little balls get sent to various stations of memory. Well, if I were to describe that process of sending those balls to different parts of the child's memory, that would be the central executive. So they have that person or people trying to manage the various memories, and they have the workstation. That would be most analogous to the central executive. And now, like I said, it plays a vital functioning in selecting which memories, applying which memories, get fully encoded and stored in long-term memory. So this process, or central executive, some people refer to it as metacognition, right? And metacognition is just thinking about thinking, or some kind of awareness about how we think and how we store memory. Now, long-term memory, I described earlier as analogous to the cloud. The cloud is limitless, so is your long-term memory. Your long-term memory, it's there forever in the absence of some kind of neurocognitive disorder where you lose your memory. But so you can have an experience when you're 6 years old and a song come on the radio, and that'll bring back that memory from when you were 6. Or there are many examples like that, so I don't need to go in that. But the idea is that your long-term memory, there's no limit whatsoever. You can hold as much as you want. And we do try and categorize things and organize things in a way that makes it meaningful. So another example from Inside Out is you will see the different stacks, so to speak, of those balls and the different kinds of memories. And different stations had different things. So one of the processes or strategies that makes long-term memory more accessible, or allows us to retrieve it, is that we have an automatic filing system where we associate things in a meaningful way so that we can retrieve them more readily at a later point. So if you look at this model basically covers the store model of information processing. So you have some kind of, and I don't know if you can see my cursor, but you have some kind of sensory input stimulus, whether it be sound, sight, taste, smell, whatever. And then you decide, yeah, this is important. I want to pay attention to this. It's going to bring it to the short-term memory. And within the short-term memory, its job is, as I said, to organize that memory in a meaningful way to further bring it to long-term memory and store it there. So once it's stored in long-term memory, the question is, well, how do we get it out of memory? Well, there is a retrieval process, and in the store model of human information processing, it tends to go from long-term memory back into your working memory and then back out. And that's the process of getting a memory in and getting a memory out. So what's the implication? How does this relate to developmental psychology? Well, we know that this system becomes more elaborate with age. So how does that work? How is it that our memory becomes more elaborate with age? Well, number one, our basic capacity increases, and the strategies we use to store a memory become more efficient, and we know how to use it better. Now, in an earlier lesson, when we talked about childbirth, we talked about the process of synaptic pruning, neurogenesis, and apoptosis, right? So if you look at that lecture, and one of the things that's relevant to memory is that most people don't remember things before the age of 3 years old. And why is that? It goes back to the concept of apoptosis, which is a biological term, which basically means programmed cell death, as well as synaptic pruning. But as our neurons start to wire and get where they need to go, we start to become more effective in our storage and retrieval of memory. Now, in terms of memory span, most people, according to George Miller, says that if you give a person a string of numbers or items in a sequence, most people can remember 7 digits or a sequence of 7 symbols plus or minus 2. Now, to me, I think that was a cool finding by George Miller, because if you look at so many aspects of your life, we use this naturally. Let's take a look at your social security number. It's 9 digits. Now, we use another strategy called chunking, which I'll talk to you about shortly. But the strategy of chunking is we break it into smaller parts. But it should not shock you that your social security number is 9 digits. And that's because that's the maximal capacity of memory span for most people. Now, if we look at a person's cell phone number, if we ignore the area code, well, how many digits are there? Well, if you ignore the area code, there are 7 digits. That too is by design. And it used to be, before there were so many cell phone numbers or whatever, if you were in a given area, you didn't even have to dial the area code. You just had to dial the 7-digit number. So that's also by design, that phone numbers are that way. One more, and then I'm going to move on. Another example is if you think of your license plate numbers, right? Usually it's about 7 alphanumeric symbols. So whether it's letters or numbers, it's about 7 there. And once again, it's based on memory span. The people who created these concepts knew that this was something that was necessary for you to recall. So they put it within your memory span. All right, so now let's look at some research. So this research is by Cowan in 1999, and they looked at the memory span of first graders, fourth graders, and adults. And they put people into 2 different categories, an attended list or an unattended list. Now, what's the difference between an attended list versus an unattended list? Well, if you had an attended list, you had no distractions that were put in front of you to prevent you from using memorization strategies. Whereas an unattended list, the researchers intentionally put distractors to make it harder for you to use some of your memory devices or strategies. Now, what did they find? Well, they found in general that research memory span increased with age and the use of strategies. So here's the data. So as one got older, you'll see that the bars tend to increase. Whether we're looking at the yellow bars or the green bars, as one gets older, then the recall or memory span tended to increase. But we see another point, and this is also relevant to when you study for tests and things like that. Those individuals who had unattended lists, distractions, or interference, well, that resulted in a lesser or a weaker number, a smaller number of recall. So when people study for tests, they like to say, oh, I'm going to study for a test, but I'm going to put the basketball game on or some television show on in the background. Well, I'm going to say don't do that, because research in it indicates that your memory and the capacity and how you store things is interfered with when you have distractions. So that was two cool findings. When you have distractions, it interferes with your memory span, and as you get older, you tend to have a better memory span. All right, so that is the memory store, the store model. Now let's talk about connectionism. So what is connectionism? So we talk about connectionism as an artificial neural network, or a fancy way of saying these are computer models to simulate how our neurons work. So believe it or not, you can simulate the memory process, the thinking process, the decision process of human beings through artificial intelligence. A good example of this is IBM Watson. So if you watch commercials, you might see Watson, and Watson seems to respond in a fluid, natural way. Well, how does that work? Well, the computer programmer designed IBM Watson to be adaptive and have learning off of other people. So the same thing could be said about how our brain works. We can map neural networks through computers. All right, so what we tend to see is that there are different layers. If we were to look at the brain like a computer, there's an input layer, and the input layer is encoding, or the process of getting something in. There's the hidden layer. That's the layer of the computer that's executing some function or performing a task. And then you have the output layer, which generates a response. Now, I'm not sure if those of you in this class have had statistics yet, but I'll give this example using SPSS. So if a person was running statistical software, you have a data file. And the data file, what is the data file? That's where you input all the scores from the research, all the answers to the questions. You put it in the data file. That's analogous to the input layer. And then when you want to run a statistical analysis, you can have an executable file or a syntax. That is most analogous to the hidden layers, where the executable file is telling it what statistics to run underneath the surface. And then you have an output layer, which is your output file, right? So it's interesting to talk about the SPSS operating this way, because when we think of computers, that's what it does. And the same thing whether you're using a Word file, when you're writing a paper. Well, the input layer is when you're typing things. What happens if you don't save the file? Well, you don't store the memory. So even though you're typing, there's something happening on the underworking of the computer that says you struck this key, and then the output is it shows up on the computer screen. If you don't save the file, and we look at this computer model, that's analogous to not storing the memory. And if you don't save the file and you close your computer and you open it up, what do you find? You have an empty Word document. That's what you find. So you need to strike the keys. There needs to be some process in the computer that says, okay, this key was struck. It needs to show up on the computer screen as a letter that you typed. And then ultimately you have to press save to hold on to it. All right. Now, connectionism, obviously you have to have a certain threshold that is hit, like neurons, in order for it to work. All right. Now, what about feedback? So it's interesting that, similar to neurons, computer programs can offer feedback and can adapt with experience. So I talked to you about IBM Watson. So if the computer does something that is correct, the connection between that input and output is strengthened. If the response is incorrect, the connection between that input and output is weakened. Same thing when we talk about learning. Well, behaviorists talk about learning and memory, that there's this concept called the law of adaptive hedonism, which means that we seek pleasure, avoid pain. So if we get a desirable outcome, such as a response being correct, we're going to repeat that behavior. It's going to strengthen that response. If we get an undesirable outcome, we're going to want to avoid that. So it's going to weaken that connection. All right. So in terms of humans versus computers, again, we find that there is a gradual internal process that occurs, and it's stage-like. Now, when it comes to human versus computer, the human cognitive system is much more general, whereas artificial neural networks or computer-based neural networks learn even slower than humans and adults. I will tell you that the curve between humans and computers is getting shorter, the distance between the two. And you have social media individuals such as Mark Zuckerberg and Facebook. They have such sophisticated algorithms that they can predict your personality, the likelihood of you wanting to click on a certain story or link. So even though in general computer models work slower than humans, there are some examples where that process has been sped up quite a bit. All right, so again, here's your input, hidden aspect, your output, and then you have your stimulation response. So again, this is your environmental factor and the behavioral output. And you'll notice the beautiful sophistication on how things move from an input to an internal processing to eventually an output. And as there are, in this case, it doesn't really reflect examples being strengthened or weakened, because there are equal number of arrows to each of the pink dots, and then following the pink dots, equal number of arrows leaving the pink to the teal. But it would be cool if you had, let's say you had these 4 dots and all but one of the arrows went to the top pink dot. Well, what would happen is that the top pink dot would have far more arrows going to the green dots, and the bottom one may not even have an arrow going out. So that just talks to the point of when you have a response that's correct, it strengthens it. So I went backwards, and when you have a response that's incorrect, it weakens it. So in the example I give, not the one on the picture, the bottom pink dot may not even have an output. Okay, so let's talk some Neo-Piagetian theories and strategy choice theory. So most people who studied Piaget's work, they've come to the realization that Piaget didn't get everything correct. He didn't fully explain the process by which people go from one stage to the next. And his timeline for moving from one stage to the next, he doesn't fully explain. So Robbie Case developed a theory that tries to explain some of what's going on and how you move between the stages and the cognitive structures. So first thing is we need to know is that he accepts the general premise of Piaget's 4 cognitive stages of sensory motor, pre-operational thought, concrete operational thought, and formal thought. But how do we get change and transformation to move from one step to the next? Well, Piaget never answered that question. So according to Robbie Case, the answer is increases in working memory are responsible for the changes that happen within and between stages. All right. And then when we talk about cognitive structures, he also explains that a little bit more. In infancy, which would be your sensory motor stage of Piaget, he says we operate based on sensory input and physical actions, right? In early childhood and middle childhood, so now we're talking about the 2 middle stages of Piaget, pre-operational thought and concrete operational thought. So now we're dealing with simple transformation and representation. So remember how we talked about in lecture 6, representational thought and mental representation. Well, Robbie Case says the pre-operational thought and concrete operational thought are dealing with basic, simple transformation. So from a memory cognitive point of view and a structural point of view. And then when we get to formal operations, which is in adolescence, now you're dealing with abstract thought, right? According to Piaget. So now he says this is explained by more complex transformation of representation. So notice how he doesn't completely uproot Piaget's 4 stages of thought. He just explains the role of memory and explains the role of transformation and transformation of representation as the reason how you move between the stages and as a reason of like how you grow within a stage. All right. So when we talk about gains in working memory, there are 3 factors responsible for increasing working memory. So we talked about brain development already. So synaptic growth, pruning, myelination. So neural connections, that's one element. Another aspect that explains how the working memory becomes easier and easier is practice. The more practice you have with a scheme, a mental scheme, the more automatized it becomes, the more automatic it becomes. So it's not as much of a cognitive load. So you easily start doing things because you've had more experience with it. You don't have to think about it. So an example might be when you first started driving a car, right? There are so many things you needed to know or learn that you were hyper vigilant. After driving a car for a long period of time, you will see people driving and they're texting while driving, they're eating while driving, they're reading the newspaper while driving. None of that I recommend, but how is it possible that they can drive and text and drive and eat and read the newspaper and all these things? It's because it's become so ingrained through the repeated practice that they don't have to think as much about driving, that they start to try and do other things along the way. So we talked about with Piaget, we have this process of assimilation and accommodation. Assimilation was the process of taking existing information and taking new information and blending it into an existing scheme. And accommodation, we said, was to adjust existing schemes based on new information. Well, the fact that the more practice you have, the schemes become more automatic, That makes it easier for you to use your assimilation accommodation process. It becomes a lot more fluid, so to speak. And then we also have central concept structures, which are there are networks that are formed between similar ideas. So we start to categorize and we start to look at things through different categories and identify things as either similar ideas or dissimilar ideas. And the more we can categorize, the easier it is to think about things with convergent and divergent thinking. All right. So continuing to explain through Robbie Case's theory, so as soon as these schemes consolidate into central concepts, working memory becomes even more expansive, and the child becomes more freed up to think about things more in a more flexible way. And as they do that, that's a transformation that happens that moves a person from sensory motor stage to pre-operational thought, to concrete operations, and so forth. So it's this consolidation of schemes and automatization of schemes and moving it to central conceptual structures that help you move between the stages. Now, we also talked about in Piaget, in the concrete operational stage to the formal operational stage, it happens in a pretty gradual way. And we used in lecture 6 the term horizontal décollage, which we said was a gradual process. So how is it that we have the horizontal décollage? We criticize Piaget and his theory. Well, Robbie Case says what happens is you have unevenness in learning and you're thinking based on the level of complexity of the task. So that as a task becomes easier cognitively, you jump and you master that. Whereas other tasks that are more complex and you have not yet mastered, it's going to take you longer to go from concrete operations to formal operation thought. Brilliant explanation. He does a pretty good job. We need more research on it, but that is Robbie Case's theory. Now, Sigler's model of strategy choice. So this is another way of explaining how we think. So Sigler operates from an evolutionary point of view. So if we talk about cognition, things have to have some level of adaptive nature to survive. And if the strategy is not adaptive, it dies out. So strategy development operates similar to evolution. If the strategy is useful, it will survive. If the strategy is less useful, it will die out. So, and it's interesting because this evolutionary process might explain why we discover that no two kids think about things the same way. Even if you give two kids the same task, their approach or the strategy that they use to solve that task might be different. And the question is, well, why is it that one child will use one strategy to solve a task and another child will use a different strategy to solve a task? So according to Sigler, it's the way their strategies evolved, and that's okay. So if that strategy is clear to that individual, they're going to use that strategy more readily. If it doesn't, if it's not useful, then they stop. So long story short, we tend to pick the strategies that work best for us as individuals, and hence the individual differences. So here's a series of bell curves. So you'll notice that the less efficient strategies, and there are 4 examples of them, when you discover that that strategy is not working, or it's less efficient, or you discover a strategy that's more efficient, you're going to switch over to the more efficient strategy and get rid of the less efficient strategies. I'll give you an example. Let's say you wanted to go to the corner store. Well, how could you get to the corner store? Well, you could crawl to the corner store, right? You could walk to the corner store. You could ride a bike to the corner store. You could run to the corner store. I want to ask you to think, how many of you would decide to crawl to the corner store at your age? The answer is very few of you, probably nobody. Why? Because you discovered that walking and running is far more efficient of a strategy to move through space. So you say, hey, why am I going to crawl if I can walk or run? So that's what happens. And it's very rare that children who learn to walk regress and start crawling. In fact, we talk about that as a disorder, child disintegrative disorder, where they master skills like speaking or walking and they regress to less efficient strategies. Typically, that's not the way it works. From an evolutionary point of view, we try different things out. If it works, we keep it. If it doesn't work, we stop using that strategy. If it works, but it's less efficient, we'll keep it in our toolbox, but it won't be our first option. So I hope that makes sense from an evolutionary point of view. We always try different strategies, and then we eventually come up with the best strategy. And that black line, or the most efficient strategy, is really the effect of evolution, according to Siegler, that we tried all these different poorer strategies. We took the good parts of it, we got rid of the bad parts, and then we came up with a more efficient strategy. Does that mean we'll never use a less efficient strategy? No. There are times we might use a less efficient strategy. Another example might be mathematics. When we do addition, subtraction, multiplication, division, we've gotten to a point where it's become automatic. So if I were to ask a person, what is 3 times 3? They would immediately say 9. And I would say, well, how do you know? What do you mean, how do I know? 3 times 3 is 9. Most people, we're so efficient that we've memorized it that we don't have to go through the process. But what I will tell you is that in elementary school, you did go through a process. And what was the process? You had rows and columns, and you put 3 rows of 3 with either beads or candy or whatever it was, and then you counted them individually and then learned it was 9. Are you going to go back to multiplication by candy and beads and things like that? Probably not, because it's less efficient. So once we develop these more efficient strategies, we use, or we spend less time with the less efficient ones. All right. So we talked about memory. We talked about Piaget. Let's talk about attention. So attention is your ability to focus on something. Now, what is sustained attention? Your ability to maintain or remain focused for an extended period of time. Well, if you look at young kids, they tend to have shorter attention spans. As you get older, you tend to be able to focus on things for longer periods of time. So once again, as you get older, sustained attention increases typically. Now, another thing that happens is that we become very, very focused. So we become more selective in our attention. Once we have mastered this concept of sustained attention, or it gets better, then we start to focus on the most relevant aspect of the task or the most important aspect and start to ignore some of the extraneous or irrelevant aspects. So, and then as we get older, we tend to adapt in our attention even better. So now let's talk about cognitive inhibition. So what is cognitive inhibition? Cognitive inhibition is the ability to control distraction, whether they be internal or external. Now, remember how we talked about that memory span and how if you have a distraction, it makes it harder to remember? Well, we have a process to focus. Now, if you want to understand one explanation of ADHD, one issue with ADHD is an inability to properly use cognitive inhibition. So everything becomes important, everything becomes a focus. So can you quiet the noise within you and outside of you? That's what we mean by cognitive inhibition. Now, as you get older, you're able to focus better, and we see really powerful changes in middle childhood. Now, middle childhood is school age years. So that's the good news, is that we typically develop growth in cognitive inhibition right in time for school. So you're going to need that. You're going to need the ability in a classroom to ignore other kids twiddling their thumbs or doodling or whatever. You're going to need to just focus on your work. So that's one thing external to you. And then internally, it's not uncommon for us to think about what we have to do next. So for example, here I am now, I'm lecturing and I'm fully present. But on the other hand, right, if someone's hearing a lecture, they might be like, after this lecture, I got to make dinner, I got to do the laundry, I got to do this, got to do that. So it's possible that you might have some internal distractions that you have to quiet down too. So cognitive inhibition is about quieting both external and internal noise. Well, how does this happen? From a biological point of view, we tend to see rapid development in the cerebral cortex, especially the frontal lobe. So when it comes to the prefrontal cortex, that is critical for being sort of like a brake valve and inhibition, making good decisions, judgment, planning, memory, and all of these things. So as the prefrontal cortex develops, your cognitive inhibition gets better and better. So that's cognitive inhibition. So let's talk about attentional strategies. We talked about memory strategies. Now let's talk about attentional strategies. So there are different strategies that occur in 4 different phases. So phase 1 is what we refer to as production deficiency. Well, production deficiency actually is a bad thing. That is when you fail to effectively use the strategy of attention. All right, so that's one problem. Then you have control deficiency. So now you use the strategy, but you're not using it consistently. So sometimes you use it, sometimes you don't use it. So as you get older, you start to use it more. So preschoolers rarely use strategies for attention. As you get a little bit older, slightly older children tend to use it a little bit more, but they have what's called control deficiency. And then you have the utilization deficiency, which is they're consistent in using strategies for attention, but we're not seeing large improvement in performance. So this might be your elementary school, early elementary school years. And then ultimately, we have the destination, which is the final point, effective strategy use. So by the middle of your elementary school years, 3rd grade, 4th grade, 5th grade, and so forth, Now we tend to see that you consistently use attentional strategies and inhibition of outside stuff, and you have improvement in performance, which is a big deal. So that's good news. We also have planning. So planning is mapping out a sequence of acts ahead of time and deciding how you're going to get to the finish line. So by middle school, you tend to have to write book reports. High school, you tend to have book reports and papers. And in college, you certainly have papers and whatnot. But what you take for granted is your planning phase. Before you ever start writing, you say, okay, well, what do I need to do? How am I going to achieve this goal? And you start mapping it out. Now, you have the seeds of planning at infancy, but it doesn't necessarily come into full effect till later. So you'll start to see in preschool years creativity. Now all of a sudden, if a kid wants to get cookies from the cookie jar, they have a routine to get the cookies from the cookie jar by preschooler. So invariably, the first thing, what do? Grab a chair. Second thing, move the chair to the cupboard. Third thing, stand on a chair. Fourth thing, open the cupboard door. Fifth thing, take a cookie out. And they do that over and over and over. So we really start to become sophisticated in our planning by middle childhood, but we start to see it happening even in preschoolers. So why did I bring up book reports and term papers and things like that? Because we expect you by roughly the 6th or 7th grade to be able to be very systematic in planning. So if you were writing a paper, the first thing you might do is brainstorming. Well, that's a planning activity. Or outlines, that's a planning activity. Or some people like to do Post-it notes and that they can move things around and shuffle the order so that they have this mental map of where they're going to go. So all of that is planning. All right. Now, we can teach planning, and it's important that parents teach their children planning so that they develop this. So let's take an activity. It's not uncommon for parents to say, let's bake together, let's make cookies together, or let's whatever it is together. Well, you can do that as early as preschool, and then take steps in a recipe and say, what do we need to do first? Okay, get out the equipment. So can you get me a bowl? And what you're doing is you're giving guidance to the child. First, you get a bowl. All right, we have all of our equipment. What next? Now we put the flour into the mixing bowl, and it goes on and on and on. But when you cook with a child or build Legos with a child, you're teaching a child step-by-step sequences which require planning. And I strongly encourage this because the mastery of planning can happen on its own, but you put your child in at an advantage if you start working with them from preschool. Now, we talked about ADHD. So ADHD stands for Attention Deficit Hyperactivity Disorder. And when we talk about it, there are really 3 subtypes of ADHD: inattentive subtype, hyperactive subtype, and a combined subtype. So how do we understand ADHD? Well, executive processing, there could be problems in. There could be problems in inhibition, right? Quieting down the noise, or impulsivity issues. saying, no, I shouldn't, just burst out with an answer or jump out of my seat. All of these have to do with the executive functioning. And remember how we talked about the prefrontal cortex as serving a brake valve? Well, it should not shock you that one of the places in the brain that we see differences with individuals with ADHD is in the prefrontal cortex. There's a reticular formation as well, but when it comes to impulsivity and things like that, we're looking prefrontal cortex. So what's the implication? What happens when a child struggles with filtering out important information from non-important information? Well, they are going to have issues in the school. They're likely going to struggle with their grades, and they might have social problems. So let me give you an example of how ADHD could affect someone on a social level. So if a person has ADHD, they might just barge into another person's conversation, or they might say whatever comes to mind before they think it through, and they could hurt people's feelings. So if you are a peer of a person with ADHD, you may not want someone to, quote, rudely jump into your conversation or say things that are inappropriate without filtering. So one of the biggest challenges is working with kids with ADHD, not just on their academic aspects, but on friendships. So what is memory? So I alluded to memory when we talked about the store model, but memory is the ability to maintain learning through time. So the process of holding on to things you've learned in the past. Now, it requires the ability to store and retrieve information at a later point in time. So some researchers, they're interested in memory loss, so amnesia, and there are different types of amnesia. So if you were to think about anterograde amnesia, that's the inability to remember new things or things in front of you, inability to store new memories. Well, let's look at a movie that really depicts anterograde amnesia, 50 First Dates. It's a cute rom-com, beautiful storyline, but think about there's memory loss. So Drew Barrymore cannot remember from one day to the next, so she can't store new memories. That's anterograde amnesia. There's also something called retrograde amnesia, which is an inability to remember past things that you previously did remember. So retrograde amnesia, another romantic movie, is The Notebook. So if you look at The Notebook, that's a very good example of an inability to retrieve old memories. And the storyline is he's reading her diary to try and help her remember old things. So some researchers, when they study memory, they're interested in memory loss. Other people, when they study memory, they're interested in people who are gifted in memory. Did you know that there's something called the World Memory Championships, where people compete in tournaments to remember sequences? And I said, typically in short-term memory, we might remember 7 bits of information, plus or minus 2. But if I were to, I'll ask it this way, and then I'll tell you something really powerful. If I were to shuffle a deck of cards in front of you and say, you can spend as much time as you want trying to memorize the sequence of these cards, how long would it take you? Right? I want you to think about that. Most people would say, oh, I don't know, a day. No, you're going to remember it much less than a day. You might remember it 30 minutes to an hour. It'll take you to remember a deck of cards. So let's say it took you an hour to remember 52 cards. What if I told you that the world record is over 1,000 cards in an hour in the right order to be able to recite the sequence? Well, there are researchers who want to know, well, how is it possible that the average person might struggle with this, but this individual is so gifted that they can remember over 1,000 cards in an hour? Well, the answer is in the memory strategies and the way they see things. So researchers might be interested in that. And then thirdly, people might be interested in what's called flashbulb memories, right? And flashbulb memories are the effect of strong emotional events on who we are. Now, I used to give this example, and I guess I should probably use a newer example, but if I were to ask people who are in their 30s, where were you when you heard about 9/11, September 11th, the attacks? People will go into vivid detail of where they were, even though it's over 18 years ago, right? So to think about that, that's pretty, pardon me, now it's 19 years, right? Pretty profound. But a flashbulb memory can be any strong emotion. So if people are getting married and you ask them to tell the story of their wedding day, many people will remember the most the smallest details about it because it has such a strong impact. Or tell me about your first kiss, things like that. That's a flashbulb memory because it has emotional value. And it could be also negative things, right? 9/11 was a tragedy, but it could be also something, a personal tragedy, like where were you and how did you process the loss of a parent, right? So if a person lost a parent and they're doing that, they might be able to describe in great detail that day as well. Now, we don't remember every day of our life to the same degree as flashbulb memories, but some memories are brighter than others. And why is it called a flashbulb memory? Because in photography, they used to use a flash or a flash bulb that would light up and make it brighter. So a flashbulb memory is a memory that's brighter than the rest. Why? Some emotional value. All right, so talking about memory and tying memory to a computer. So just like a computer, you have three phases. You have encoding, storage, and retrieval. These are terms that I might have slipped into our lecture earlier, but I didn't define. So let me take a moment to define them now. So encoding is the process of moving information into a memory or getting a memory in, so to speak. Storage is a process of holding on to a memory or retaining a memory. And retrieval is a process of accessing a memory at a later point in time. So if we go back to that Word file, we talked about typing the Word file. Well, if you don't press save, then you didn't store that Word file on your hard drive. And if you didn't store that Word file on your hard drive, when you come back to that Word file, it's going to be blank. Same thing with memory. If you don't fully encode the information to its final destination, long-term memory, then when you try and access that memory, you're not going to be able to. Now, I talked to you about the sensory register. Sensory memory is your initial sensory information on memory. Short-term memory is limited in time and capacity. Long-term memory is limitless. So here is a graphic of the Atkinson model of memory. So you have a sensory input from the environment. I talked to you about a balloon popping. You might not store that. You might ignore that right away. But if it's important and you pay attention to that information, it's going to go into a sensory memory. Then you're going to focus on the most novel part or the most important part of that bring it to short-term memory, and then you're going to go through whatever rehearsal strategies that you have to finally encode it and store it in long-term memory. Now, the one thing that I don't like about this graph, I believe, and you can see my cursor here, under long-term memory, the word storage should be there, because you have encoding, you have retrieval, but you don't have the process of storage. And storage would be under long-term memory. All right, so what do we encode? Typically, we don't memorize things verbatim. So we don't remember word for word the last book we read or the last movie we watched. We tend to remember the gist, which is the most meaningful aspect of the book or movie. So if someone says, oh, tell me about that book, tell me about that movie, you're going to tell them the general meaning of it, the most important aspect of it, but you're not going to say it was the best of times, it was the worst of times, and quote the book word for word. So that's the first thing. So we encode meaning, we don't encode things exactly how they were stated. Now, we also use imagery as a process of encoding. So things like mnemonic devices. We all use mnemonic devices to help us remember things. So if you've taken a statistics class, you probably have heard the mnemonic PEMDAS. Now, PEMDAS is the new way of saying it. When I was taking statistics in the 7th grade, we used the mnemonic, please excuse my dear Aunt Sally. Well, you just cut out the whole sentence and just made it an acronym. P stood for parenthesis, E stood for exponents, M stood multiplication, division, addition, subtraction. You get the idea. So that abbreviation, that acronym, is a mnemonic to help you remember the order of operations in algebra. We use tons of mnemonics. Now, it doesn't have to just be an acronym. It could be any auditory, visual, acoustic cue that you find useful. All right. We also organize the information. And I said to you, I would talk to you about the area code. And I said, we'll talk about, you know, if we ignore the area code, you have 7 bits of information, right? So one way to take information that's larger than 7 bits is to chunk it or group it together. So if you look at a cell phone number, believe it or not, it has 10 individual numbers, but it actually has 3 chunks because you have the area code, the first 3, and then the last 4. Your social security number, which I brought up, has 3 chunks, your first 3, your second 2, and then your last 4. Your license plate has 2 chunks. So the idea of chunking is to take large bits of information and chop it up into smaller, more manageable bits. All right. Another thing we use, aside from chunking, which is an organizational process, a second organizational process is hierarchies, flow charts. So when I teach neuroscience, if I wanted to talk about the nervous system, well, I would write at the top of the board, nervous system. And then I would subdivide it into 2 pieces. And on one side, I'd say central nervous system. The other side, I'd say peripheral nervous system. And then under central nervous system, I would do brain and spinal cord as the subdivisions of the central nervous system. And then the spinal cord, I could subdivide into cervical, thoracic, lumbar, and sacral spinal cord and subdivide that. And then the brain, I could divide it by different parts. You get the idea. Then the peripheral side of that hierarchy, we would have somatic and autonomic. Somatic nervous system, you have voluntary control over. Autonomic is involuntary. And then within the autonomic nervous system, we might have sympathetic nervous system, parasympathetic nervous system, and visually I can make it at the top and have branches growing down. Well, when you do these flow charts, when you do these hierarchies and subdivide it into its smaller elements or subcategories, that actually is a memory aid that helps you. So I strongly recommend the process of hierarchies. I also talked to you about rehearsal. Rehearsal is the process of repeating information. Well, there are different ways to do rehearsal. There is a standard repetitive rehearsal where you just repeat it as it is. I use the example of trying to memorize a phone number, just repeating it over and over and over. But there's a more elaborative form of rehearsal, which we refer to this strategy called organization. And now we're trying to not just repeat it over and over, but we might tell a story around it to help us remember the information. So we talked about memory. Let's talk about retention and the role of repetition or rehearsal on retentive information. One of the best studies ever done in the history of psychology was done by Hermann Ebbinghaus. This study was done on one person, and that one person was Ebbinghaus himself. And 150 years later, we maintain the same findings. And what was it? He took a string of letter, consonant, vowel pairings, and he memorized the list. How did he memorize the list? Through rehearsal. So he repeated the list over and over and over until he got it correct. Now, in some scenarios, he stopped there, and in some scenarios, he repeated the list even more. And what happened was he measured the amount of time it took him to relearn the list on day 2. And what did he find? The more times he rehearsed or repeated or reviewed the list on day 1, the shorter the amount of time it took him to relearn it or reacquire that list. Now, I say this to students that you should read your notes out loud in advance of a test. And you should read it out loud over and over and over. And I say a minimum of 4 times. And each time you repeat the notes out loud, it's going to be faster and faster to do it. But the more you review it, the easier it is going to be when you prepare for the test the last day. So more effort in the initial learning results in less effort at a later point in time. So increased rehearsal results in decreased time for relearning and so forth. Now, elaboration is a strategy as well. So now you're creating relationship or shared meaning between 2 or more bits of information. So let's say you had to remember 2 words that were not members of the same family. So instead of, I'll just give you the example, then I'll say how this strategy works better. So let's say you had to remember fish and pipe. You might say that the fish is smoking the pipe. So that's elaboration. Now, you can envision Dr. Seuss and the fish smoking a pipe. Whatever mental imagery you have, you're going to link those words together. Now, naturally, it's easier to link fish and bird together than fish and pipe. So you're going to need to use elaboration strategies more often when the information is not of the same category, because there's no real connection between fish and pipe naturally. All right, so this strategy tends to show up and help in middle childhood and becomes very common in adolescence, and you probably do it in college as well. So what are some other things we see about memory? Another thing we see about memory is the next in line effect. I want you to think about, have you ever been in a circle of people trying to introduce themselves? Uh, if you do, we see the next in line effect is as follows. You'll remember what most people said, except for the person right before you. And the question is, well, why is it that you don't remember what people said right before you? Well, you were practicing what you were going to say, so you tune them out. So one thing with memory is if you're going to answer a question, you're likely going to remember at least the people who went before you or the information that went right before you spoke. Spacing effect. Many students think it's a great idea to study the day before the test, which we refer to as cramming. Well, we find that if you spread out your learning and studying, you actually do better because you break it out into smaller bits of information than cramming. Another thing we see is that people tend to not remember the things right before they went to sleep. And I'm not talking about your regular nighttime. So there are people who will stay up all night before a test. This is actually a bad practice. It's better to get a good night's rest and then approach it in the morning, because when you're studying through the night, your eyes start glazing over and you're not encoding anything. Now, if your bedtime is typically 10 p.m. And you're studying 9 p.m. to 10 p.m., that might be good because there's less interference. But if you're studying at 2 a.m. when your bedtime is 10 p.m., you're not really getting it. Other things, we have something called the serial position effect. We tend to remember things at the beginning and the end of an event more than what happens in the middle. And the question is, well, why? Well, things that happen at the end, if you test it, it's still in your short-term memory. Things that happen at the beginning are well encoded in your long-term memory. All right. Another thing that we talk about is the difference between recognition and recall in memory. Recognition is the ability to identify information you've seen before. So if you ever have a test that's multiple choice, you don't have to come up with the answer. You just have to identify which answer is most correct. Whereas recall, now you have to generate the information on your own, which is harder. So essay tests and fill-in tests are much harder than multiple choice. That's actually why I choose to do multiple choice tests, because it's a little bit easier because you don't have to generate the information on your own. All right, so now how about reconstructing memory? How about accessing memory at a later point in time? So one thing we know about reconstructive memory is that it's not always accurate. And we see research by Elizabeth Loftus, something called the misinformation effect, that when we try and recreate a memory, we might add information that was not actually true and build it in to the memory. So that's a problem. We also talk about fuzzy trace theory. If you've ever heard a rumor and that rumor was debunked, you might still have some connection with that person and a rumor, even though it's not true. Well, how does that happen? Well, there's that fuzzy trace that says, I vaguely remember hearing a story about ABC, whatever it is, and you link on to that and you remember the gist, and then you build a memory around that fuzzy version of the story. All right, so in terms of memories, there's different other forms of memory or memory scripts. So we talk about declarative memory. So if we were doing memory, we could subdivide memory as well. And one division would be declarative memory or explicit memory. So within explicit memory or declarative memory, we have semantic memory and episodic memory. Semantic memory is just remembering general things like who was the 16th president of the United States. Well, that's semantic memory. Maybe you remember, maybe you don't. It was Abraham Lincoln, if you're wondering. But that would just be just random facts and information. Episodic memory are things that happen or particular events, right? So we create scripts to help us try and describe what occurred in a given situation. Well, these scripts or these storylines for these episodes also help in taking these experiences and making them just a matter of fact, right? So scripts play a role in reconstructive memory. Autobiographical memory, again, this is story of your life. We tend to not remember things before the age of 3. Your book refers to this as infantile amnesia. And the question is, how do we have infantile amnesia? Well, there are different factors. We talked about the changes in the brain on a neuronal level, but we also talk about on a structural level, so the frontal lobe and the cerebral cortex change, and so it makes you unable to access that old memory. We also develop self-image, which affects our memory and what we think is important. So we tend to focus on self-image, and then how, when we develop language, our verbal understanding affects how we see our memory. All right. So when we talk about autobiographical memory in preschoolers, they typically talk with adults and they share the story and they form it collaboratively. So, but in reality, there are different conversational styles, right? So an elaborative conversational style, the parent asks questions, adds information to the, adds more information for the child, shares their own experience to build a fuller memory, right? So that's an elaborative conversational style. Do you remember when we went to Disney the first time? You might ask a kid that, right? And then the kid will describe their event, and then the parent would describe how they saw it, and it puts together and make a fuller autobiographical memory. But there are other processes. A weaker form of a conversational style is just repetitive. So instead of asking new questions, adding new information, you just ask the same question over and over. So you have less detail, less meaningful stories. Now, eyewitness memory, we know that eyewitness memory is problematic. And in fact, in forensic psychology, we know that about 4% of people are in jail inappropriately based on eyewitness testimony. 4%, if you do the math, that's 1 out of every 25 people in jail are there due to some kind of eyewitness testimony that we eventually discover is not accurate, right? So, but eyewitness testimony, it has some meaning, and as we get older, we're able to describe our experiences and what we saw a little bit better. And as we get older, we're not skewed by parents' accounts as much. So that's important. So the credibility of eyewitness testimony increases with age. All right. So why is it that younger people make more errors? Well, we said maybe their language is not fully developed, so it's harder, it's more difficult for them to describe the event or answer the question appropriately, but they do the best they can. When you ask a yes/no question, which is probably not good for eyewitness testimony, there's a natural tendency for young children to want to please the person asking the question. So they'll say whatever they think the person wants them to say. That's a problem. And then in terms of source monitoring, many times they don't remember where they got the information, but they state it as fact anyway. We know children tend to be suggestible, pardon me. So if a person asks leading questions, children are going to be much more likely to report false information. So this might happen in cases of divorce where one parent uses the child against the other parent and asks questions in a very negative light. That child might start to see the other parent in a negative light. And this is what we call parental alienation. So suggestibility, asking biased questions, could also impact how children tell their stories. So stereotyping a person as bad or labeling a person as bad is going to increase the likelihood of a person telling more negative stories about that individual who's bad, so to speak. So how do you address some of these problems if you want to get more accurate information? So one thing you could do is to ask open-ended questions, have practice interviews before the child comes in, prompt the child to disclose details without you adding it, and have a friendly, warm interview tone. Try and avoid negative judgments or facial expressions that might alter their response. All of these are ways to get more accurate information. So now let's talk about forgetting. We talked about memory and increasing memory and holding on to memory and relearning. But let's talk about forgetting. How is it possible that people forget? Well, one factor, if we talked about the computer model, you have encoding, storage, and retrieval. Well, let's look at those factors, right? You could have an encoding failure, which is a process of not fully moving the information to storage. So you didn't fully encode it. Storage decay is if you don't continue to work on a memory, it will gradually dissipate naturally. So for example, if you learned another language and you don't use that language, naturally you're going to become more rusty with that language. Because even though you learned the language, since you're not using it, it's going to get weaker. Now, we also have retrieval failure. So interference, I used that word a few times during this lecture. Interference is something that gets in the way of a memory. So there's something called proactive interference. So this is what we call a disruptive effect of prior learning on recall of new information. So if you learn something wrong the first time, it's all that much harder when you're trying to relearn it the right way to actually get it. Because the way you learned it the first time, if it was incorrect, it interferes with learning new stuff. So that's proactive interference. Retroactive interference occurs too. Now, remember when I said 3 times 3, what is it? 9. We don't always think about how we know it's 9. So if I were to say, prove it to me, and I were to argue 3 times 3 is 33, right? Just move the 2 3s together. Unless you can remember earlier, more primitive ways you learned by putting the 3 rows, 3 columns, then you're likely going to just say, how do I know? I just know. So we don't remember the more primitive strategies or the weaker strategies we use when there's a more efficient strategy. But so that's all about encoding, storage, and retrieval. There's another factor here called motivated forgetting. There are some times that we experience something that's traumatizing and we don't want to deal with it. So we can repress it or suppress it, which is taking that memory and pushing it beneath the surface so we don't have to deal with the anxiety around it. Now, this is Hermann Ebbinghaus. Just like we did a relearning curve, he had a forgetting curve. So 30 days later, he said, well, how did I do in terms of recalling nonsense syllables? Well, on day 30, he went from remembering 60% all the way down to about 20%. Now, I like this graph because it tells you that you have a significant drop off in the beginning, but eventually it plateaus. So, for example, let's talk about foreign language one more time. I learned Spanish in high school. I took 3 years of Spanish. I wouldn't say that I'm as proficient in Spanish today as I was, but I find myself still knowing what people are saying, even though I can't produce the language as well as I used to. So even though I forgot much of my Spanish, I still have some. So when we talk about forgetting, you don't forget everything. There is a certain amount that stays with you to help you in the relearning process, actually. So in terms of memory, we talked about perspective and retrospective memory. Perspective is remembering new things. Retrospective is remembering past things. And I talked about the two different kinds of amnesia. Anterograde amnesia is not being able to remember new things, and retrograde amnesia is not being able to remember old things. So let's talk about metacognition. Again, this is thinking about thinking or having awareness about thought. There are different pieces of metacognition that are worthwhile here. So the first thing is a naive theory of mind, which is basically knowing that people, understanding that people are mental beings, knowing that you have thoughts and other people have thoughts. Now, one thing that you can engage in is mind reading. And I'm going to take off my clinical psychologist hat, I'll take it off for a second. But what is mind reading? Mind reading is the ability to detect your own and other people's thoughts, feelings, beliefs, etc. And the more we know a person, the better our mind reading is. But now I'm going to put on my clinical psychologist hat again. One of the problems with couples and families that they fight about is making assumptions about what another person might be thinking or feeling. And we also call that mind reading, but we don't always get mind reading correct. So in therapy, we say, well, how do you know that person was angry with you? I just know. Did you ever ask them? No. And then you encourage them to do the exercise of asking, and they discover that person was never angry at them. They were just distracted or whatever it might be. So even though we engage in mind reading and we can detect our feelings and other people's feelings and thoughts and beliefs, we're not 100%. So you want to check that a little bit. And then in terms of our metacognition, as we get older, we tend to become more accurate in understanding other people's thinking as well. So you'll notice a common trend. As you get older, you tend to become more proficient in most things. So, all right. So in addition to your view of your mind, you move from a passive thinking entity to an active cognitive processing entity, and it occurs in different ways. So we talk about comprehension theory. Knowledge expands through understanding cognitive capabilities, understanding better strategies or employing better strategies, and understanding things that either interfere or help development. So I said that cognitive capacity increases with age, right? So how does that happen, right? Well, as we get older, we start to develop an awareness of things beyond that which is observable. So if you're a 3-year-old, you might think that thinking actually occurs in a person's head and that's just it, right? But what you know about knowledge and thought is very limited, right? You might rely on looking at pictures and reading books and very tangible things. But by 7 or 8, you start to think about things beyond things that are directly observable. So, all right. So this is a Flavel study and Hovel thoughts, right? So is talking about how you think and having awareness of knowing that you actually are still thinking. I guess that's the best way to say it. So, all right. So 5-year-olds and 8-year-olds in this study were asked to don't think. And then you ask them, well, did you think anyway? 8-year-olds will say more often than 5-year-olds, yeah, I was still thinking. Because most 5-year-olds don't know that even when you're told not to think, you're still thinking. And you might be thinking, I'm told not to think. So that metacognition, that meta-awareness, that you're actually having thoughts and they're staying with you, 8-year-olds have greater awareness of that. So cognitive self-regulation, so understanding the flow of thoughts and controlling the flow of thoughts, that also develops slowly and increases. So if you ever have a 3-year-old, ask them to tell you a story, they might jump around in their story. But as you get older, you might have a very logical, flowing, linear story that occurs. So it's interesting that even your cognitive self-regulation, right, increases with age. All right. So I think that that's not all that important. But let's shift to the application of this lesson today on academic learning. So what's the point? Why this lecture of information processing? Well, first thing is that researchers are trying to identify how people perform, how they develop memory and thinking and tracing their development. And they're trying to understand what internal processes help a person who's a good learner from a poor learner. And I hate to use the word poor learner, but a person who's not demonstrating good outcomes. So you want to try and use information processing to try and say, okay, what are these micro skills that these good learners have? And so information processing allows you to look under the hood, so to speak. So cognitive skills that we might look at and see differences in are reading, mathematics, science, all of these things. So when we talk about reading as a skill that we're trying to understand differences in learning, so we see things called emergent literacy, and this is basically children understand much more about the written language before they can actually read and write it. So preschoolers have an understanding of things they can't write sentences about. I said by 6 years old, you have a word bank or a language bank of about 10,000 words. Doesn't mean you're going to write sentences with 10,000 words. So we see young children understand more than they can articulate. Now, this process, we see preschoolers being shaped gradually and starting to improve their reading ability through encounters with whether it be teachers or adults who help them along the way. They also develop a phonological awareness, underlying phone, like phono always refers to sound. So they understand how sound plays a role in spoken language. Now, we have a lecture 9, all on language. So I'm not going to go into great detail right now, but phonological awareness, the ability to understand and manipulate sounds, plays a role in reading ability, reading knowledge and spelling achievement and so forth. So that's important. So the question is, well, how should you read to your child, right? So this is an application. So there are different ways people do this. And ultimately, I'm going to argue that each of the ways have their own benefits. So one way to read to your child is the whole language approach. So in this approach, reading occurs and it's taught in a way that parallels natural language. So they're being exposed to books in their complete form. Now, if you read a bedtime story, the whole language approach would suggest that you have to read the whole story. Don't stop or read a page from it. Read the whole story because it allows them to understand a logical progression. A phonetics approach is now you're reading more simplified material, but you're reading it and you're coaching them on sounds or phonics. So is it best to read the whole story? Is it best to read simple stories and focus on sounds? The answer is children learn best when you combine the two. How about mathematics reasoning? Now, in lecture 6, we learned about concrete operational thought, and we learned about abstract operational thought. So we learned ordinality. We know the order of numbers. So even toddlers can identify relationships between various numbers. And then we learned cardinality. This is by the age of 4, which is understanding the quantity of a set. So you might say 1, 2, 3, 4, 5. And then you point to a child and a child would say 6. That's cardinality. And that is the lecture in a nutshell. So I'm going to stop there. But are there any questions that you have? I know I see at least one person who sat through the lecture. Do you have any questions on information processing? Yes, no? Okay. Well, in the absence of questions, I'm going to stop there and I'm going to end this Zoom call, and then I'm going to share the video link on Blackboard. Take care.
Just one quick question. When is the discussion post going to be due on the